All right. Hi everybody, my name is Nir. I'm a co-founder and CEO of Eureka Labs, operating the Eureka Builder. How many of you guys heard about us? Great crowd. Woo! So we came out of sales last week and announced something we like to call programmable blocks, which is a very fancy way to say that we're doing very fancy things on the block builder itself. Basically, I'm going to go over 4 different use cases of how anyone can use programmable blocks to do cool stuff. The whole idea of what we build is the idea that we're not the smartest guys in the room, and we'd like you guys to keep thinking about how you can use these technologies to actually build new cool stuff on top of it. So if any of this is interesting to you, feel free to find me or anyone with the blue logo on their shirt. We're around here.
Before you get going, could you maybe make a connection between programmable blocks and the spam topic that I was talking about before?
Well, honestly, spam is something that we are dealing with internally. As I'm sure the Flashbots have the builder net, so in some way every builder has to deal with that internally. And there's different ways to do that. So honestly, when we launched this, we thought of making it from day one completely permissionless, so anyone can spam us. But we prefer to open it, in a permissioned way in the beginning to see how it's being used. For example, one of the features allows anyone to run very large transactions, like gigagas transactions. In our lab, I think Eddie, my co-founder, ran almost a 10 gigagas single transaction in a block. And that takes us, let's say, about 20 milliseconds, which is pretty nice. But if we would start getting thousands of those, that'll be a problem to start optimizing for everything. That's why we prefer to open it slowly, so if anyone is interested, talk to me, we'll give you guys access. We actually want you guys to use this. The main reason it's not completely permissionless is because we're scared of spam. So as a block builder, we know how to deal with spam on regular transactions and bundles. This is a little more advanced, that's why we're taking it cautiously. All right, so let's start. So the main thing that when we're thinking about the block builder is that up until now, all block builders just take transactions and they order them. So they try to maximize revenue. Everybody are doing that because they want to win the PBS auction, which is nice, makes sense, that's how things work. But when we started thinking about the block builder, we said, this could actually allow to do things that are otherwise impossible. So we had previously the S-loaded store, sorry, I don't remember the exact EIP number, 81 something, sorry. And he was going basically in the same direction, even though I think that might be a little tricky on the Ethereum Foundation to push that, but different topic there. I'm rooting for him because that will help us to do a lot of stuff, but it's not easy. So those things we can actually do already today inside the block builder. We can make the block builder not just be an ordering mechanism, but an actual execution mechanism. We can basically build applications and things that are otherwise completely impossible, and I'll get to a few examples of those in the future. So the 4 things that we're doing is capital, computation, external signals, and execution guarantees. Each one of these is a different primitive that we built into our builder, and each one of them allows completely different use cases. The thing that I'm excited the most, and I actually got someone I was talking to earlier today, is someone actually figured out how to combine 2 of these to build one very cool strategy, which I'm hoping he'll implement, but we'll have to get back to the office to see that. So, the first one. It's a simple one, most of you probably are aware of that. So if you want to run JIT, just-in-time liquidity, which I think is a net good for the end user, because they get better price execution. The main challenge is that if you're trying to do this with a blue chip token, that's very nice, because you can get access to it, or some big market makers have that. But if you want to do this on a little longer tail tokens, usually you don't have access to those. If you want to try to improve, for example, an execution of an Aave token, just came out of my mind, then you need to get access to those Aave tokens in order to improve the pool liquidity and give the user better execution. We can actually give you access to those using something we call intra-block loans. It's an ability to, again, like a flash loan, but instead of being limited to a single transaction, it can be extended to a whole block. You can get access to that liquidity that otherwise you don't have. You don't want to take the inventory risk of holding those tokens for the long run. You can make 3% on a transaction, but lose 20% when the token goes down. We can give you access to those, and you can run this complex transactions that otherwise impossible. So if any of you have like any idea of a strategy or anything you want to build that requires capital for more than a single transaction, because that you can do probably with a flash loan, talk to us, we'll be able to provide you that liquidity on a block level. And again, first use case is pretty simple, that's JIT. Second one, something we're calling Builder Execution Extension or BEX. Again, the idea is to allow anyone to run as big as computation as they want without paying any gas. So imagine running a 10 gigagas transaction, doing a lot of storage access, a lot of heavy math computation, and eventually paying zero gas in that transaction. How is that possible? Because what we do is we separate the transaction into two parts, into a pre-compute and an execute. The pre-compute is simulated in the block right before the execution, and in that transaction you can do anything you want. You can do very heavy math calculations. You can do, for example, checking thousands of different pools, doing a very complex math, even WASM code that can do almost anything, and find a very optimized end of block, for example, arbitrage to balance everything that happened in the block, but you don't pay for all that calculation. The output of that calculation will be a simple struct that will be fed into an execute transaction that will just execute the arbitrage. So think about being able to do things that are today completely impossible, because again, 16 million gas limit, and of course no one wants to pay 16 million gas to do a rebalancing at the end of the block. Today, you can do that. Using our Builder Execution Extension, there's no more limits to the calculations you can do on-chain to the access without paying any gas. So that's the second cool thing. Third one, this is actually something cool that we did like a POC in our lab. It's something we're calling Builder Oracle. The idea is that you can get access to external information while we're building the block. So you can define in your transaction in a very simple way to tell us as the builder that when we're building the block, we'll access an external server, external information to get something that you might need. For example, we're talking the other day with guys that want to get price feeds from some external places and feed them directly into the transaction while we're building the block. The use case I actually want to talk about here is something that one of our engineers actually did in the lab, the POC, is that injecting a Google 2FA authorization into the transaction. So imagine you have a wallet, basically anyone who gets access to your private key can sign it. What he did is he built a special proxy to the wallet, that the only way to sign a transaction is if the builder, basically when you're sending the transaction, you're inputting into the transaction data your Google 2FA authentication, and while the builder is building the block and verifying the transaction, we go to the Google 2FA server, which again, if you want to really do this in a decentralized way, you can put it in a TE, so you don't have to trust us as well. For the POC, it wasn't done that way. But you access the 2FA Google authentication, and only if the code that the user put into the transaction matches whatever the Google authentication server says is correct, only then the transaction is valid and can be executed. In any other case, for example, if this transaction will get to another builder, or if another person gets access to your private key and tries to send a transaction without inputting that, the transaction will fail because basically your proxy, your wallet is locked and cannot do anything without this kind of approval. This is the cool kind of thing that you can do when you're actually building things into the block builder. So our idea is to empower people who want to do things like this. I mean, I've been having some conversations today about people around prop AMMs or stuff like that, or for example, randomization of transactions while we're building the block using external verified random. There's a lot of cool things you can do when you actually have access to the real world while the block is being built. You don't need to rely on chaining to update their prices hopefully once every while or stuff like that. You have full access of what you want to do and when, and it's 100% verifiable on Block Builder. So this is a cool POC that one of our engineers built. And lastly, deterministic location. So it's the ability to define that you want something to happen in some cases. Like for example, you want your transaction or your bundle to run after something happens. I'll give you an example. There's rebase tokens, you're probably all aware of them, and there's certain times when there's an external oracle that updates the rebase token, so depending on the token, certain things could happen. Imagine if you want to target that rebase transaction, which you don't know when it's going to come, usually doesn't come from, I would say, a fake. Usually, I wouldn't say usually, but sometimes it's not being background. So you can basically say, I want my strategy, I want whatever I'm doing to run exactly after that. I mean, we have users using this for, of course, the end of block. We're talking to a few about top of the block without hurting, I would say, other entities that are doing it. We're targeting specific pool changes. This is a kind of a different use case that is not, I would say, trivial. It's not being heavily used today, but the idea is to you be able to enforce any logic you want. Be able to tell us as a block builder, I want my transaction to, for example, happen after this or that or a few conditions, and we'll be able to make sure that that happens while we're building the block. That's the last thing. So just to summarize everything, the idea is we're trying to make the block builder a new design place, to build new MEV strategies, to build new primitives, to build new applications. You can get, as I was saying, like endless amount of external capital without any collateral. You can get endless computation, outside information, and execution timing exactly. What we're thinking when we're thinking about programmable blocks is we're basically changing the block to be an execution environment. It's not just a container of transactions. You know, you're all aware that a block is a JSON of transactions. We want you guys to stop thinking about that and think about the block as something active, alive, that can actually do things while it's being built and even after that. And if any of this sounds interesting, or if you have ideas of stuff, cool stuff you can build on top of this, happy to have a chat.
What are some of the risks you take on when providing like intra-block liquidity?
So, in theory, zero. There's always smart contract risk. But the capital, because we as a block builder, we get the bundle from you, and we make sure that the loan is repaid at the end of the bundle. So if there's any reason that something failed there and the loan wasn't repaid, then we basically have the option to exclude the entire bundle and not give you the loan in the first place. That's our job, to make sure that the liquidity provider's money is safe.
Yeah, what about reverse?
So we have ways to fix that, to protect against that as well. We have a few protection mechanisms. The first, which is the simplest one, is basically a timestamp, which is the block is being run after some time, then the transaction won't be valid.
So, and clarification to whether, are you guys a builder?
So we are a builder. So,
Okay,
so
then do you see this as more of something that, so when do you see this as sitting in the supply chain, just
So-
how do you build the shell that like a new primitive that anybody can use?
So great question. So we're block builder as well. Some of these, I mean, we're talking to a few other builders to maybe integrate it with them as well, like to be able to build it in I would say in an extendable way that other builders can get access to it. I would say in a way some of it is easier and some of it is harder. So it depends on the exact feature. Like for example, intra-block loans, and we get access to that liquidity. So the liquidity providers in a way needs to trust that someone that has access to their money. At the moment, they're trusting us that's sitting on a TE, but if tomorrow I want to give access, for example, to someone else, let's say, I need to make sure that that entity doesn't have the ability to move funds without the liquidity provider's permissions. That's a little bit more complex.
Just for clarification, you're saying to treat the block as an execution environment. Is the order fixed and now treating that as an execution environment, or can I think about the ability to reorder?
So the order is never fixed. I mean, the order is always changing, and it depends on what we're trying to execute during the block. So certain things, for example, if you want your transaction to happen in a certain place, or after certain things happen, then maybe you're telling me, you know what, I want my transaction to happen after all the calls to this contract have been done. So we are the one making sure that that condition is met. So we'll see 6 different calls to that contract, and then we'll put you exactly after the last one. And that's why the block is still a dynamic thing that needs to be built in different ways. But while we're building it, we're not just trying to extract the maximum value. We're actually trying to enforce some logic while we're building the block.
Yes. For the off-chain execution, like you also mentioned, like it would not just be EVM, but also WASM or like anything else.
Yes.
How like in what way would you executors and how you like, you assume some notion of metering or like limitation, not necessarily in gas, but like in processing, right?
So the easy way to do this is just solidity code that we're simulating any other transaction. But while we're simulating the transaction, we have the ability to run pretty much any code. WASM is just like a simple way to do this because we can support pretty much any language. So while we are simulating the transaction, we see that basically the WASM code is wrapped in a very specific way that we detect while we're simulating the transaction. And then in the middle of the execution of the transaction, we run that code in the block builder backend, like in our server. And then whatever happens after that is fed to the rest of the contract. And the end of the contract, basically result, is fed to the execute function. That answer or like?
I was thinking more like what limitation,
What limitation?
The practical side of it.
So,
Because I like the idea, I'm just like more concerned, like, not concerned, but like, I'm interested.
I'll do it like this. So we have a limitation internally that we don't want any transaction or computation transaction to run for more than 200 milliseconds. That's just like an arbitrary number we put inside to make sure that we're building blocks properly. I mean, I can tell you that we've simulated, my partner was here, I think it was like almost 10 gigabytes transactions, and that took us way less than that. So that shouldn't be a problem. If on your WASM code you start doing stuff that will take a lot of time, like in a very non-efficient way, we'll need to maybe have a separate conversation about it. That's one of the reasons why this is still permissioned and not permissionless. But if the use case makes sense, we might extend that a little bit more. So I think it's a case-by-case basis on that. Yes.
There must be, like, if you get broad adoption, there must be cases where there's so many conflicts to solve that you can't do it anymore, right? So there's so many conditions to try, and like, especially for Docker Dynamics, you were saying, you need to go back and like try again something that you simulated before. So how do you handle that?
So it's an absolutely valid question. The way we're doing it right now, for example, without this, like any other block builder, we're learning what wallets and what transactions makes more sense to simulate first. And we're gonna do the same logic here. I mean, if a searcher or any party starts sending us, bundles that require a lot of computation, but they're valuable and it makes sense to do them, then we'll give them priority. If someone is sending a 50 million gigagas transaction and is paying like 2 cents for that priority for that transaction, then I'm not saying we're not gonna include that, I'm just saying we're probably gonna give this a lower priority. So it's a matter of building that ranking system internally. And completely honestly, we're still learning, and we want the first users to start onboarding this so we can learn how they're using this and how to prioritize. Yep.
So, having been in the blockbuilding space for a while, we've had similar ideas, and I think the one concept that might be relevant here is this concept like build a gas, right? Because there's, I guess, like I would say there's 3 things that if I were to categorize these use cases, maybe you see more or see it differently, but like one is access to fresh information. The other is just like computational cost arbitrage. So if you have gas, even if you have snarks, so that would be even more expensive and gold is cheaper. And then the third is just like making the search, the ordering process more effective. Like you were talking about people saying, oh, only execute this transaction if this other thing has happened. That could be implemented in the EVM most of the time, but they'd rather tell you that so that the builder can do the ordering more effectively. That's a very loaded question, but the thing I wanted to get to was, I guess one question is, how do you charge for this? And in particular, does the following make sense to you? In the sort of cost arbitrage, having this concept of builder gas, which is like, it's a resource, you have limited compute you can do at the block builder, it's still scalable, more scalable on chain, as you charge for it like that. Have you thought about the economics of this?
So we had a lot of discussions around this, and we were thinking of something similar to that, like charging a fee just for doing the simulation and stuff like that. At the moment, we decided against it for 2 main reasons. The first one is we actually want people to use this. So even if it costs us a little bit more to compute, we need to put maybe a stronger server. We prefer people to start using it to learn how people are using this to build cool new stuff, and we're willing to subsidize that builder gas cost. So that's, I would say, the first reason. The second one is that this is eventually supposed to be, reflected in the priority fee. So if someone is sending me a 10 gigahertz transaction, but he's paying $100 priority fee, and someone is sending like a 50 gigahertz transaction, and he's only paying like 50 cents, then of course I'm gonna prioritize the first one. And also in the long run, I'm gonna start building that reputation, and I know that user, that wallet makes more sense for us to do it on the long run. If we start getting maybe spam too much and we need to somehow start calibrating that, we might go there, but honestly, we really don't want to go to a place where we need to start charging like builder gas in some way. We much rather optimize it internally by a ranking system, and then if someone is not getting enough attention, they can always talk to us and we'll try to give them attention to see if that makes sense. I'm really hoping we wouldn't have to go to builder gas, so I would say that's the short answer. Yep.
Is it possible, or have you thought about enabling it, for that code that runs before my transaction to be stateful? So, for example, I want to submit transaction to block n and block n+1, and whatever runs before my transaction to block n computes something so that I could access that computation in block n+1.
So that's a really good question, and something we kind of had an internal thought process around. The main issue with that is that we don't know that we'll be building the n+1 block. I mean, even if we build the n and we set certain things, and I mean, we're making it in some way stateful, I cannot guarantee to you that I'll be building the n+1 block. And that's the main problem with us saving states between blocks. Would it make sense, if there's any use case that you think that it makes sense to make it stateful even without a guarantee between blocks, happy to have a discussion about it, and talk. I mean, we're completely open to exactly stuff like that.
Cool. Thank you.
Last one.
The third point where you get outside information from an API that you can call. Have you thought if there are ways that searchers or other people can game this by calling their own API depending on the block state and then leaking information out through that mechanism? Or?
So long discussion, and then Ed is smiling because he was on the other side. I mean, I wanted to make it completely open, and he said people are going to do exactly that. And that's why on the first stage, it's not open to any API. I mean, it needs to be open to APIs that we're going to whitelist. I mean, we have a certain amount of APIs that we created or we whitelisted ourselves. And if someone has an API that it's very important for them to do something, of course they can talk to us and we're whitelisted that as well. One of the things that keeps us up at night is how do we make this completely, on one hand, like permissionless, and you can call any outside API without leaking information or making things that are harmful. I want to say we have a few ideas. We don't have a final solution. So at the moment, if someone wants to add a new API to this, it needs to go through us. We need to understand what it does, and we'll just whitelist it.
Yeah, I think there'll be more. Yeah, we can wrap it up there.
Yeah, I was just gonna say thank you.